Hello, welcome to ME 510, Economics and Policy of Engineered Energy Systems. This presentation is part one of a three-part module on the future of natural gas. The presentations in this module are based on a report by the Massachusetts Institute of Technology, and we'll go over some of the key highlights from that report. To put the use of natural gas into context, if you look at the US energy demand, we consume on average about 100 quads per year. A quad is essentially 1 quadrillion BTUs, and it's a good measure of how significant different energy supplies are to the economy. You can think about them as in percentages. So if you look at natural gas, about 23 to 25% of our energy comes from natural gas. Petroleum is obviously the dominant source, but also coal and renewables are a growing source of energy. In this chart from the Energy Information Administration, we can see how each of the supply sources are distributed in the US industry. About 30% of the natural gas goes towards electric power, where it contributes 18% of the total electric power consumed in the US. 32% goes to industry, where it contributes 40%, and 35% of natural gas goes into the residential and commercial market. That's what we use for heating, for example. In that market, natural gas dominates, providing 76% of the energy used in that sector. Okay? We do use a little bit of natural gas in transportation, mostly in the form of compressed natural gas, but as you can see, a small amount of the natural gas is used in that way, and it only contributes 3% of the transportation sector's energy consumption. Most of the natural gas that we use come from what are called conventional resources. These are called high quality or low quality reservoirs, where natural gas can be extracted using conventional technologies. However, this is only a small amount of the available natural gas, or estimated available natural gas. There is a large amount of unconventional natural gas that is currently tied away in what are called tight gas sands, coal bed methane, shale gas, and particularly methane hydrates. We're not going to spend a lot of time on describing each of these different unconventional resources, but I do encourage you to do a Google search on each of these, particularly methane hydrates. Supposedly, there are centuries worth of energy available in the form of methane hydrates, which is natural gas that's stored away in ice encasements deep in the oceans. In principle, any of these unconventional resources could become a conventional resource if the economic and technology factors become sufficient in order to develop these fields. To give you an idea of how these different fields compare, you can see here on the left, conventional non-associated gas, that's the easiest one to find. You drill a hole, dig down, put a pipeline, and due to the pressure in that particular pocket, the natural gas will flow out of the reservoir. However, there's also natural gas found in what's called gas-rich shale. One of the biggest challenges with gas-rich shale is that it's very difficult to drill vertically down towards the reservoir, and oftentimes you have to use horizontal drilling. Horizontal drilling is one of these recent developments that took several decades to develop, but that has enabled the US in particular to recover many of these difficult to reach natural gas reservoirs. Natural gas can also be found in tight sand gas, in conventional associated gas reservoirs. These are reservoirs that include both gas and crude oil, liquid oil, and those the conventional ones have been developed for quite some time. What we're going to see in future slides is that it's non-conventional natural gas that has been driving most of the development and extraction of natural gas in recent years. You may remember the McKelvey diagram from oil extraction that we covered in the module 2. Here's a similar McKelvey diagram for natural gas. The concept is exactly the same. The amount of natural gas that has been discovered and identified includes both confirmed and unconfirmed sources of natural gas, whether they are economically viable, will depend on multiple factors, both technology and economic based. And there's always a large amount of undiscovered, technically recoverable resources that are out there. And we can't discard the fact that some natural gas resources may never be technically feasible to recover. As I mentioned earlier, we have seen a steady increase in the production of natural gas across the world. But in recent years, if you ignore the little blip between 2008 and 2009, what we'll find is that North America has led the increase in production of natural gas. So let's talk a little bit about the factors driving that. Uh, Between 1992 and 2012, the United States has seen a dramatic increase in the production of natural gas. So dramatic, in fact, that we went from number 2 in worldwide production to number 1, overpassing Russia as the second largest producer. You can see here a list of other major natural gas producers around the world, but it's clearly clear here that the jump that the United States saw in this period is unprecedented, and that no other country in the world has been able to match the sheer increase in natural gas production in this period. This natural gas is often found in remote areas that are not close to residential locations. So another way of keeping track of this growth or is to look at how that natural gas is transmitted to consumers. In 1993, most of the natural gas, again, came from conventional resources. Those could be piped directly to consumers, and that was the majority of the case. However, we've seen that in addition to increases in pipeline delivery of natural gas, there's an increase in the delivery of liquefied natural gas. Liquefying natural gas has some additional costs, both in terms of the compression process and the transportation process. But at least in 2008, the market conditions were favorable to justify getting natural gas from locations that may not have pipelines available. Now, if you look at reserves that are available, this is not production. Remember, if we look at countries, the production rates from different countries, the Middle East was not among the top 5. But in terms of reserves, they do seem to have a large amount of reserves. The United States comes in at 3rd place in terms of reserves. And that also depends on estimates for how much unconventional gas the US might have. Russia and the Middle East have larger numbers of total reserve and also conventional undiscovered reserves. The United States could continue to become a natural gas production leader if they're able to recover the unconventional gas. Otherwise, they'll still remain at 3rd place, but much further away than Russia and the Middle East. This final chart here just shows how much is being produced around the world. Again, the United States, one of the largest leaders in trillions of cubic feet of natural gas that could be available from methane hydrates. As I already mentioned, the amounts of methane hydrates around the world are supposedly large enough to sustain humanity for several centuries, if not millennia. However, it's a resource that's difficult to recover and one that could have significant climate impact effects. When you recover the natural gas from these ice formations, it leads to a lot of flaring, a lot of methane being emitted into the environment because it's hard to capture the effluent gas. And so even though the promise of this methane hydrates is large, there's a significant concern that exploiting the methane hydrates could have detrimental impacts on the climate, let alone the economy, given the high cost it takes to recover. If you want to read more, I've provided a link here on an article from the Japan Times. Japan, because they have very little natural gas, conventional natural gas resources, they're heavily interested in the development of these methane hydrates, of which they have quite a bit in their surrounding waters. And now we'll move on to part 2 of natural gas discussion.